Significant figures, counting and rounding. When making measurements in science, we express all of the digits we know for sure in one and only one estimate. In this case, 1.76 centimeters would be an appropriate measurement. It turns out we call all the known digits in one estimate significant figures. Sometimes this is shortened to sig figs, other times we call them significant digits. Often it's useful to be able to work in reverse. How many of these were known? How many were estimated? For that, we need to have some rules for counting significant figures. Rule 1 is that every measured non-zero digit is significant. So in this case, a measured value, we've got two digits that are not zero. So we have two significant figures. That means that we knew the 3 and we estimated the 7. That can tell us something about the ruler that was used to make this measurement. By looking at the number, we can actually work backwards in our mind to have an idea of what the ruler looked like. With numbers like 1,000 milliliters, it's more complicated, and we need rules to figure out what to do with the zeros. The rule we'll use is called Atlantic-Pacific rule. For reference, in case it's been a while, the locations of the Pacific and Atlantic Oceans. When a decimal is present, we start counting from the Pacific or left-hand side. When a decimal is absent, we start counting from the Atlantic or the right-hand side. Always start counting with the first non-zero digit, and once you've started counting, count everything, even if it's a zero. In this case, decimal point is absent, so we start counting from the Atlantic. Never start with a zero. We have one significant digit here. That means that the 1 must have been estimated. Again, if significant figures are all of the ones we know in one and only one estimate, then a measured value with one significant digit is just an estimate. Decimal point here is present, so we start counting from the Pacific. 1, 2, 3, 4 significant digits here. The 951 being the known digits and the 0 being the one estimate. Pacific, decimal point is present. Never start counting with a 0. There are two significant digits here. Absent, no decimal point present, starting from the Atlantic, never with a 0. 1, 2, 3, 4. Decimal point present, starting at the Pacific, 1, 2, 3, 4, 5, 6 significant figures. Scientific notation makes our lives easier. We only need to look at the coefficient. We apply the same rules. In this case, the decimal is present. Starting at the Pacific, we've got two significant figures. Often it's useful to round significant figures, and we use conventional rules of rounding to do that. In the case of 951.0 grams, we first figure out using Pacific that we've got 4 significant digits. But we were asked to round to 2. So we look at the second significant digit and we apply the conventional rules of rounding. 1 is lower than 5, so our rounding becomes 950 grams. Checking to make sure we only have 2. Now we're Atlantic, no decimal. Never start with a 0, 1, 2. Scientific notation is also a viable option, and it makes it even easier. 9.5 times 10 to the 2 grams. Again, only counting the coefficient, 2 significant figures. We now have 2 significant figures as addressed earlier. We wanted 1, so we need to apply the conventional rules of rounding. 0.0006 meters. Checking, Pacific, start from the Pacific or left-hand side, 1 significant figure present. A number like this can lead to some confusion because of the 0. The easiest way to do it would be 1.0 times 10 to the 6 joules.